Okay, 7.5, Solving Trig Equations, Part 1. Strategies for solving trig equations. When solving an equation that involves trigonometry, first isolate the trig function, meaning get the sine, cosine, tangent, etc. Get it by itself. Then solve for the variable. Write the equations in terms of only one trig function. Substitute using a trig identity to change one trig function or expression into something that it is equal to. Meaning I don't need to have sine over secant plus tangent equals this. I need just a sine or just a cosine. Then it says use a trig identity to simplify an expression, isolate the trig functions before solving for the variable, and remember to pay attention to degrees or radians based on your directions. So let's go ahead and dive into one of these. Solve each equation for x being in between 0 and 360 degrees, so we're in degrees, and also not equal to 360 because 0 and 360 hold the same number value. We would answer that with 0 and not 360. Alright, so we are in degrees. Alright, so cosine of x is equal to -1/2. So what I'm going to do is, I know some special right triangles, and in this case, since there's not a square root of 2, it can't be my 45, 45, 90, so it's going to have to be a 30, 60, 90. So I can go ahead and label across from 30 is 1, across from 60 is square root of 3, and across from 90 is 2. Alright, so cosine is adjacent over hypotenuse, so we'll test out 30. Adjacent over hypotenuse for 30 degrees is square root of 3 over 2. So this is not 30 degrees. So then I look at 60. Adjacent to 60 is 1 and the hypotenuse is 2. So this is a 60-degree angle. So I'm going to denote that by circling this. It is a 60-degree angle. Where is cosine negative? Cosine is negative here and here in quadrant 2 and 3. So I need the 60-degree measure in quadrant 2 and quadrant 3. So what is my 60-degree measure in quadrant 2? Remember that reference angle here is 180. So I'm going to take and say 180 minus 60, and that is 120. 120 degrees, and then in quadrant 3 we're going to take and say 180 plus 60, and that is 240. So x is equal to 120 degrees and 240 degrees because that is where cosine is equal to -1/2. Let's try another one. Solve each equation for x is between 0 and 2 pi but not equal to 2 pi. Alright, so here we're in radians. Alright, so for a problem like this, I first need to simplify this trig function. So we're not even really going to do anything with the square root of 3 over 2 just yet. So what I want to do is change tangent to its quotient identity. So we've got cosine x, and now tangent is sine over cosine. And so what's going to happen with my two cosine measures? They're going to cancel. And so that's going to bring me to sine x equals square root of 3 over 2. Alright, so this is going to be a 30, 60, 90. So I'm going to come right here and draw a 30, 60, 90 for reference. And then we're going to see sine is opposite over hypotenuse. So for 30 degrees, opposite over hypotenuse is 1/2. So this is not 30. This again is going to be a 60 because sine here is square root of 3 over 2. Alright, so where is sine? Positive. Sine is positive in quadrant 1 and quadrant 2. Alright, so 60 degrees in quadrant 1 is 60 degrees. And we're writing in radians, so 60 degrees in radians is pi over 3. Quadrant 2, 60 degrees is 120 degrees. And that in radians, remember you say, why did I keep typing 180? 120 divided by 180. And that is 2 pi over 3. So my two answers are pi over 3 and 2 pi over 3. Alright, we're back to degrees for this one. X is between 0 and 360 degrees. Alright, here we have cosine 2x minus cosine squared x. Alright, so cosine 2x is 1 minus 2 sine squared x. So that would give me sine squared. Cosine squared is 1 minus sine squared. So let's do that. That would both give me sine squared. So let's do that. All right. This is our double angle. And we're going to use Pythagorean. I cannot spell. Identity for this one. Alright, so let's do that. Cosine 2x is 1 minus 2 sine squared x minus cosine squared x is 1 minus sine squared x. And I put that in parentheses because that was two terms and there's a minus in front, so there's going to need to be some distributing there. So I'm going to say 1 minus 2 sine squared x minus 1 plus sine squared x equals 0. So I've got some like terms here. 1 and negative 1 are gone. And now we have negative 2 sine squared x and positive 1 sine squared x, which is going to give me a negative sine squared x equals 0. Okay, so from here, if I wanted to get sine by itself, I would need to divide by the negative, which would just give me sine squared x is 0. And then if I took the square root of both sides, I'm going to get sine x equals 0. So now I need to find in degrees where sine is 0. Alright, so if I have my xy coordinate plane, this point would be 1, 0, this would be 0, 1. This would be negative 1, 0, and this would be 0, negative 1. And remember that sine is a y value. So here, sine is 0. Alright, so that's one of my options. 0 degrees. Here, sine is 1, so that's not my answer. And here, sine is also 0, and this is 180 degrees. And then this would give me negative 1, so that's not my answer. So my two answers are 0 degrees and 180 degrees. solve each equation for x is between 0 and 2 pi. Alright, so this one is looking for radian measure. I'm going to get my answer in degrees and then I'll convert to radians. Alright, so here we have 4 cosine squared minus 2 equals 0. So I need to try to get cosine by itself first. And since there's not multiple trig functions, I'm not trying to use an identity to flip or change anything. So let's go ahead and work this. I want to get cosine by itself, so I'm going to add 2 to the other side. So 4 cosine squared x equals positive 2. And then I want to divide both sides by 4. And that's going to give me cosine squared x equals 1/2. And then I'm going to need to square root both sides. And that's going to give me cosine x equals plus or minus. So I'm going to be looking for both positive and negative answers. And then this is going to give me 1 over the square root of 2, which I need to go ahead and rationalize to be plus or minus the square root of 2 over 2. Alright, so that's what we're looking for. Cosine of x is equal to plus or minus the square root of 2 over 2. Alright, so anytime I see the square root of 2, I think about 45, 45, 90 triangle. So that's what I'm about to draw. 1, 1, square root of 2. Because in this case, cosine is adjacent over hypotenuse, and that gives me 1 over the square root of 2, which then rationalizes to the square root of 2 over 2. So we're looking for 45 degrees all around every single quadrant, because we're looking for both positive and negative answers. So in quadrant 1, that's going to be 45 degrees. In quadrant 2, it's 180 minus 45, which is 135. In quadrant 3, that's 180 plus 45, which is 225. And in quadrant 4, that is 360 minus 45, which is 315. Yep. Alright, and my answer is supposed to be in radians, so 45 degrees is pi over 4. When 35 degrees is 3 pi over 4. 225 degrees is 5 pi over 4. And 315 degrees is 7 pi over 4. So those are my 4 answers. Again, we had 4 answers as we were looking for both positive and negative values. One more example. We're in radians again. This time we have multiple trig functions, so we're going to have to do some changing and converting using identities and such. Alright, so I see cosine squared, I see sine squared, and I see tangent. So what I want to do is put everything on the left. So that's what I'm going to do first. Move it all to the left. Equal to 0. Alright, so if I move sine squared over, it becomes positive. And if I move tangent over, it becomes negative. Alright, so cosine squared plus sine squared is my Pythagorean identity. Which is sine squared plus cosine squared is 1. Alright, so now I'm down to one trig function. 1 minus tangent x equals 0. So now I'm going to solve for tangent because I got rid of the extra trig identities. So now we need to get tangent by itself. I can just add it to the other side and have 1 equals tangent x. And so when thinking about tangent and just having the number 1, I think about a 45, 45, 90. Because tangent is opposite over adjacent, and that is 1. So now I just need to see where tangent's positive. Everything is positive in quadrant 1. Over here, sine and cosine are opposites, so that's not going to give me a positive outcome. Here, sine and cosine are the same, so whenever I divide, I will get a positive. So tangent is positive in Q1 and Q3. All right, so 45 degrees in quadrant 1 is pi over 4. And we just answered this, I believe. No, we did cosine. All right, so quadrant 3 is 225. 5 pi over 4 is also where tangent is a positive 1. All right, if you have any questions, comment below.